In this video, we're going to finish up our MPLS full mesh section, and we're going to start getting into the other sections like the partial mesh and getting into VPN route reflectors and all other good stuff that goes along with it. And would you believe it? Actually, I wanted to show you exactly what I did, so you guys would believe me. Obviously, we couldn't ping in the previous video. We couldn't get the connection between router 19 and 9. We couldn't get the BGP peering up. So we even went as far as reloading router 19, right? Well, once it came back up, I, go in here and I did everything I could to get it operational, as you saw. And pretty much right after I finished the video, I went ahead and I bounced the interface. And what do you know? The circuit comes up. I was like, are you kidding me? So yeah, well, it happens. So basically, it's up, it's operational, and then I did a show IP route, and then I got a bunch of BGP routes in here. Now, what this doesn't show here, and this is the funny part. Remember how I mentioned where if you have the same autonomous system number on both your customer, both customer sides, so in this case 65,000 or 2.20 here and 2.20 here. Well, what's going to end up happening is when this guy sends a route to this guy, well, actually I should say this way, when this goes this direction, what ends up happening is this autonomous system number, so in this case we are 2.20. When this guy comes into 65,000, it then goes 65,000 and 2.20, right? As long as this guy is got the Bgp Aas notation dot set up so that it's going to be able to read the 4-byte autonomous system number. That gets echoed over here, and so these guys are both sharing the BGP route. And then when it gets sent down to here, it's actually rejected. And the reason it's rejected is because when R19 takes a look inside of the BGP update, it sees its own autonomous system number in the AS path field. It sees 2.20. Well, that can't happen. So there's two ways of getting around this. You have one where on R19 you type in the command bgp allow ASN, and you do that on both ends. And the reason you do it on both ends is because R19 can advertise a route to R14, and R14 can advertise a route to R19. Well, technically the way we have it set up is I've set it up to where when you advertise a route, all of your BGP or your MPLS customer sites should be receiving MPLS service. They should be receiving routes. So, with that being said, you should be able to get traffic regardless of where it is in the network. Well, it's not going to happen if you don't have a way of filtering that AS path information out, so that you say, okay, if I see my own AS path information, I'm going to take care of that. The other way is with the Bgp Aas Override Command on the provider side. This is done when you go in and you set it up to where when it sees that autonomous system number come in, it goes ahead and it flips that autonomous system number out with the provider's autonomous system so that it doesn't look quite as bad. So we'll actually demonstrate that real quick for you. It's actually really easy. So on R19, if we were to go to global config, type in router BGP 2.20, or type in BGP question mark, and near the top here you have it's a neighbor. Neighbor 199.0.0.9, and you look right here, it says allow ASN. So accept AS path with my AS present in it. So if we were to type in that and allow AS in, and then you could say a number of occurrences of AS number. So for instance, you could be doing like prepending or something to that effect. So you could do that. Now what's going to end up happening if we were to type in do show IP route. Now before I type this in, I want to scroll up a little bit here for you, just so you guys can see. One thing you won't see in here is the 1014 network. So if I was to go to 14 real quick and then scroll up here, you're not going to see these routes. The reason why you're not going to see these routes is because of the fact that these routes are advertised from 14, they won't be learned in via BGP. So we go to 19, we don't see those routes in the routing table. So 10.4.14 isn't there. If I do this command and I do show IP route, now you do. You see that route come in. Now notice the time on it is 37 seconds ago. Now I have to do this on both sides. The reason for that is because R14 might be receiving a route from 19. So if we were to go to 19 and do a do show run pipe section BGP, and I don't believe I'm advertising anything, and I'm not. So if I was to go create a loopback, type in interface loopback 100, type in IP address is going to be we'll say 19.100.19 24-bit mask, and type in router BGP 2.20 and type in network 10.19.100.0 with a mask of 24 bits. Oh, 24 bits, not 32. We go over to R14, we do a show IP route. What you're not going to see is you're not going to see that route come in. So it's going to be, I punched it in as 10.19. So it would be, I always do 10 and then the router that's advertising it. So we come over here and you do show IP route. The 10.19 route is not coming in. So if we were even to do a clear IP route star and effectively call for a route refresh, nothing's happening. So the way we would fix this is we would go to router BGP 2.20, type in neighbor, and then the neighbor is going to be the 148.0.0.8, allow ASN. Then we jump down here and do a show IP route again. Then we'll get the 10.19 route in. Voila. So that's how you would get that to pop in if you really wanted to have the routes in there. Now that's two-way. You know, you got to have it going back and forth. Now, what that also means is anything that's being advertised via BGP. Now, that's not going to affect your routes that are coming from non-BGP peerings. So, for instance, EIGRP, where if we look right here, we're getting the route from the connection between it's supposed to be a 123. Oh, that's right. That's actually a 132 route. So we're getting that via BGP. And the reason why it's coming in via BGP is because these routes, this route right here is not advertised from 12 to 11 as BGP. So if we were to take this a step closer, we would be able to go in there and, well, we really can't take a step closer because the BGP is not running here. But what we can do, let me just bring this down just a little bit. The other way we can do this is we could go to the provider. So in this case, we could go to router 8 and go to global config, type in router BGP 65000, and under the address family IPv4 VRF brown, we could do neighbor, and we could type in 148.0.0.14 question mark, and if you look right here, you have AS override. AS override says override matching autonomous system number while sending update. What that means is if you have a route come in with 2.20 and you want to send it out, so this case would be AS override, it's going to pull the AS information that it's receiving in and replace it with its own. So in this case, when R19 would receive it, he would receive it as it's coming from router the provider's autonomous system number, or 65,000. That's the other way to do it. So that's pretty much it. I just want to make sure you guys, so we had full reachability. Now there's a couple other ones that I will be talking about coming up here. Mainly the ones that I wanted to discuss with you before we go into the next section, or wrap this video up, or this section up, is the OSPF Sham link. Again, when you're on R5, and I'll pull R5 up real quick for you. R5, if you do a show IP route, OSPF, what you're going to get is you're going to get a bunch of inter-area routes as long as they're coming from router 4. And the reason you know it's coming from router 4 is because of the fact that you have 43 is on this network right here. You have the 4 network. You have anything advertised, anything really advertised from router 7. Now, granted, the 10.100.2.2, that's in the OSPF domain over here. 10.100.3.3 is router 3. 10.100.4.4 is coming from router 4. That is why, and then in the 46 network, that's why all of these routes right here are showing up as inter-area. And the 10103, well, 10103 is between router 3 and or 10 and 13. And this is coming in from EIGRP. Well, it shows up as an external type 2 route. You can't do anything about that one, but you can go in there and set it up to where it shows up as E1, or you can modify the cost. You can play with the administrative distance, things like that. The inter-area routes, the reason why, again, why they're coming up in here, and let me go to the provider edge, and we're going to do a show IP OSPF. If we look, let me see if I can find it. It's in here somewhere. I just got to find a link. Yes, right here. It says connected to Mpls Vpn Super Backbone VRF Red. Now what that means is the provider is running MPLS and he is running OSPF. Now I haven't tested this with the EIGRP, and we will, because it's important to test all the IGPs as the IGP to LDP mapping. So if I just run OSPF and then all of a sudden we decide to jump in and the lab throws EIGRP at us, because you can do a fast reroute with it, which we'll be covering later on down the road. It's like, oh, so definitely something you would want to pay attention to when we're going through. We'll take a look at that coming up later on, but it's one of those things where you have to understand what's going on. The super backbone, again, is, and I don't want to go into a ton of detail here because I've already covered this inside of the Advanced Technologies class, but basically what the super backbone is this is the area 0, and so area 0 is on all these routers right here, and that's how, actually I should say it's all of these routers right here. So I have to be careful where I draw the line, because some are, some aren't. So that's the area 0 domain, and including all these guys. Now EIGRP is up here, but that's a different story. Now with that being said, with these routes being advertised the way they are, you have to be careful when you're dealing with this, because if you were to do a sham link between 6 and 7, okay, so you were to do basically a sham link is almost like a virtual link where you try to bridge the area 0 network over a non-transit backbone. So basically what that means is if you have area 0 connected to a router, and then you have another area, so this is 0, this is 1, this guy right here is the non-transit backbone, because of the fact that he is not area 0. The area 0 is always the transit area, because of the fact that all routes should transit area 0. That's how OSPF is designed. So with that in mind, if you have another router here and you put area 2 over here, a virtual link is going to allow you to take this and advertise unicast LSAs to bridge OSPF area 0 over area 1 in order to bridge the gap, so area 2 could then become part of the OSPF domain. Virtual links were never designed to be to be used other than to bridge something into like bridge two networks together, or fix something that was broke, or it's a band-aid until a redesign can be taken place. So depending on the situation, I've never had to use one. I know what they're like to use, but basically a sham link does the exact same thing. So what you're doing is basically you're taking the OSPF area 0 flooding domain and you're bringing that into the provider edge network, and what that does is it takes all of your area 0 routes, because technically now you've got, because area 0, well, the OSPF itself is a leaf spine leaf. So you have I'm going to draw a triangle, a leaf, a spine, and I'm just going to draw a line here, and then another leaf. Well, if this guy is area 1 and this guy's area 2, this guy has to be area 0, or else it's not going to work. You're not going to be able to get connectivity through it. Now this would be a valid design because of the fact that both routers would be touching area 0, as long as one link on an ABR is, to be considered an ABR, you have to have one link inside of area 0, right? Well, the same kind of thing happens here. As long as you have at least one link in area 0, you're good to go. Now if this was area 1, that would not be the case. You'd have to create a virtual link down to here in order to bridge that gap. So with a sham link, it brings the OSPF area 0 domain into the provider's network, Now the drawback to this, and this is where it gets a little interesting, when you're dealing with normal Area 0 routing with PE to CE routing, it's easier to work with than it would be if you were to insert a sham link. And the reason why is because when you have a Area 0 link, or if you have no sham link on the provider edge routers, what ends up happening is that there's a flooding event of some type on R5. That flooding event goes as far as the ABR, which would be this guy. The ABR would receive the LSA update floods, and that's it, because an ABR is a flooding domain boundary. So LSAs aren't flooded beyond the ABR or in the ASBR. So they hit that, they set the ABR, and then that's why it's called an area border router, because you have multiple areas attached to the same router, and then that's where all of your information is saved. Now, that's why the Type 3 LSA is where it's at, regardless of whatever type of network you're running. Type 3 LSA is going to be there. Type 2 LSA can come and go depending on if you're running broadcast or non-broadcast, but Type 3 LSA is always going to be there because you need to have an LSA that's going to identify the ABR. You need a Type 4 LSA to advertise the ASBR. And those are just summary routes that it's basically doing. That's why you had the stub and the not so stubby area and stuff like that you're able to run with. Now, with regards to that, if you have a sham link configured between 6 and 7, what'll end up happening is that there's a link, there's a flooding event or a reconvergence event in OSPF over here on R5, R4 gets affected. Because what you've done is you've now brought the Area 0 domain into the provider's network, and you're going to transit those LSAs across the sham link. Therefore, a flooding event will go completely across to this guy, and these guys will run SPF. So think about it this way. I've never heard of anybody that's actually run this, but the capability is there. So let's say, for instance, we had OSPF here, and OSPF here. And just for good measure, let's throw it over here too. Well, the problem with that is going to be is if this guy floods and there's runs SPF, whether it's incremental or a full SPF run, doesn't matter. If anything happens on this guy, anybody that's touching Area 0, and there's a question, can you run sham links to all those other sites? The answer to that question is yes, you can. The way you would do that is you can do this almost from a route reflector type of setup, to where as long as you have reachability to this guy's loopback, you can do sham links to all these guys. And so they could all be running OSPF across the providers, the PE routers. So if there's a flooding event here, this guy, this guy, this guy, this guy, and this guy all run SPF. Now that's bad news in a network. You never want to have to run SPF if you don't have to. So it's better to not use the sham link. And realistically speaking, I've only deployed MPLS a handful of times in production, and every time I've done it, we peer with BGP. I've never done it with OSPF. It's very, very easy to do that, but I've always done it with BGP. It's just easier to do that, and go from there. So that's basically what I wanted to cover with you. I will demonstrate this, but I just wanted to kind of rehash it because I'm at the end of the video and going from there. So the next video, I've actually added a piece to our setup here. It says ensure BGP PE to CE routing advertisement works from the same ASN. So basically what that means is you're going to do what I just did a few minutes ago. You're going to go in, you're going to set the allow ASN, or you're going to set the Bgp Aas Override, and so you have that flexibility. So you don't want to get yourself into a position where you can't figure out why it's going in. And quite honestly, when I was doing the original CCIE topology, the first one with the really, really big topology, 30-some routers, when I was trying to get BGP routes to traverse, I was running into a problem where they weren't coming in. And it wasn't until I did a debug and I actually watched the updates come in, I was just like, oh, okay, that's why it's not working. So, like I said, it's one of those things where it's important to run through the config at least a couple of times, and the main goal for this is to build something up and play with it, see how it actually works. And I feel like this topology is pretty big, and if you want to take it any farther, you can you're more than welcome to do so. I've got everything saved, so the configs, and I've got the topology set up, so I will be putting that up on Google Drive here pretty soon. But as it sits right now, this is what we're going to be running with and going on from there. Now, another thing that I want to throw out there, there's been a lot of references lately. I'm getting a lot of emails from people that are looking for IOU, which is going to be the platform that you use inside the CCIE lab. I don't have it. It's, technically speaking, it's you shouldn't have it, and so I think it's, if you do have it, well, that's on you. But anyway, I don't have it, so don't bother asking for it. So I don't have it. And there's a couple other people that have asked for some of the documentation that I've done in some of the older series that I've done for like CCNA and CCNP, and that stuff. That's just random stuff that I pull off the internet, and that hard drive died like a year ago. So you're kind of out of luck. I mean, if you do, I don't even remember where I had that stuff, to be honest with you. It was a spur of the moment. Oh, what's this? Oh, okay, download it and use it from there. But it's one of those things where, if I have it, I will be more than willing to share it out to you. But if I don't, I have to let everybody know, hey, I don't have those documents anymore. Just search Google. Cisco Live is a great resource. Go up there, and usually they'll have the presentation and they'll have the session video. Open up the presentation, download the PDF. That's what I do, and go run through the PDF. It's follow along when you're watching the video. Take notes on it. Usually, what I'll do is I'll write down page 1 or page 33. Note on EIGRP over the top, which we're not going to cover that, but the possibility is there. So stuff like that. But other than that, and I don't want to sound like I'm dogging on anybody, or making fun of anybody or anything like that. I'm totally not. That's not my intention. But I figured, just so you guys know, I don't have what you're looking for, and just to be clear on that. So, but then again, if those of you that have watched the channel and you're a subscriber and this is benefiting you, great. I'm glad it's a resource that you can use. That's why I do what I do. I don't get paid for it. I don't receive any compensation from it. What I do get out of it is what it does is it literally forces me to go through the technologies and really learn them, because I don't want to be that guy that on the internet that just talks and doesn't actually know what he's talking about. There's a lot of people out there, and if you go to like YouTube and you search up, say, SEAL Team 6, gets murdered after killing Bin Laden, okay. I feel bad that the people died. Sorry. My condolences go out to their families, but I don't understand the big deal. Why people want to sit there and the conspiracy theories and the government's out to get them, all that type of stuff. I don't get into any of that. So where I spend the majority of my time is right here, going through these videos, going through documentation. I've got better things to do with my time than to sit there and dig up, did the Navy SEALs really kill Bin Laden? Yeah, they did, as far as I'm concerned. But anyway, that's just a for instance. But that's kind of where I'm at with this. So I've got a lot left to cover, and again, I'll be doing a partial mesh setup. And what I'm thinking about doing with a partial mesh is going through and doing like I'm thinking. Unfortunately, right now every router is connected. So what I'm thinking is having router 9, because he's going to be he may or may not be totally used all the time, because I may not always need the BGP peering. So what I think I'll do is I'll do now you got me thinking. And this is my thought process. So just so you're aware, in case you're still listening, R9 and R8 are going to be used for BGP site of origin, and for doing BGP multipathing, and for load balancing Mpls over the peerings. So we're going to have that. And additionally, 11 and 10 are needed for EIGRP for site of origin, because the whole point of site of origin is when R10 advertises a route this way, it's potential he can learn it back in, R13 can advertise a route this way, R13 can advertise a route this way, this guy can go this way, this guy can go that way. So as you can see, the potential for a loop is pretty serious, so you want to eliminate that with the site of origin. So same thing goes with BGP. You can advertise a route this way, you can advertise a route this way, this route can get advertised that direction. So again, it's one of those things where we're understanding how the flooding works and how the routers are going to handle that. So that's definitely a potential. There are other ways you can do that. You could always create a prefix list in here to deny a route out, or do a distribute list, or do like an outbound route filtering on here and say, hey, I only want to get these routes from you if this matches a prefix list, and stuff like that. But that's my main goal. I will be doing OSPF Sham link. I'll be playing with inter-area versus intra-area routes, that type of stuff. But once I get through MPLS, I think we'll be in good shape. Again, I'll come back to it later on and do some other ones. There's actually a really good one that I want to share with you real quick, since I so got you here, and it's this guy right here. This one is I really want to try this, and it actually was written by a CCIE, Rene Molinar, nice guy. This is Rene. Basically, what he does is he tells you, here's the scenario, so blah 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 blah. The nice thing about the way he writes his labs is they're all scenario based, whether they're just who you are, and he kind of sets the precedence to how well you should do. So now if you go through here, this is the goal, and then he gives you all of the details for each VRF and the router and all the goodies. So there's a lot of detail to go into this. This is the topology. Now this is an advanced Mpls Vpn setup. So as you can see, you have Melon's branch, Melon's HQ. You have central server, you have internet, you have Palm branch, Palm HQ, Coco HQ, branch 1, branch 2. And then you have the MPLS core, right? So that's actually a pretty unique situation, and he even goes in here and does RIP and OSPF and OSPF and OSPF and OSPF and EIGRP, BGP. So he gives you a lot of flexibility with how this actual stuff gets all put together. So it's actually really cool that he did this, and I believe the solutions video for it is something in the area of like 3 hours. So actually, I was thinking about doing something similar to this, but this is pretty heavy. So you've got 1, 2, 3 customers. You've got it set up for Central Services VPN, which this is typically used when you want to provide like network monitoring, or you want to provide say email or some sort of web services. So like for instance, you could be AT&T, and let me draw this up real quick. You could be AT&T. Let me take this back a little bit here. Okay, so you could be AT&T, and for instance, let's say R19 is your behind R19 is all of your web servers, your database servers, and you want to provide internet or you want to provide network monitoring, email, web, and spam filtering for all of your customers. It's a service you offer. So what you do is on R9 is you set your route target import export up to where it's going to import all the route target values that are 8, 7, 6, 11, and 10 advertised to 9. So they'll all be able to import, and then this guy will have route target exports to all these guys. Now this is what they refer to as a hub and spoke, or, which is actually really cool, is unified MPLS. This is actually what I think Cisco coined the term, but unified MPLS, where you would use some advanced techniques and stuff like that to get this like split horizon, and with the like EIGRP, like no IP split horizon, and add path, and all that stuff that goes along with it. This is where that type of stuff would come into play. So, well, we will cover central services. I will touch on internet VPNs. So in here, where to go? Internet VPNs, where you can actually advertise a default route into your VRF, and you can give your VPN connection actual a default route. Basically, no other routes exist. This is how you get to the internet. So you can almost double up your services to a customer if you'd like. So both private WAN circuitry or circuits, as well as default internet, for global internet routing, that type of stuff. So I would definitely check out gns3default.com. It's got a lot of good stuff up here. If I was to take a step back here, and it gives you a lot of filtering, like label filtering, and frame mode MPLS, and then this is what it is by default, frame mode. Cell mode is when you're using ATM. And then Ethernet over MPLS, we'll take a look at that later on. It's actually just one command on the CE or the provider edge routers, where you actually turn on, you do an X connect. So it's actually I keep doing that. Pull up Paint, where literally on like the provider edge, and say we'll do 11 and we'll do 6 and 7. So on 7, you would go config T, and then you would, I'm not sure, you put it underneath the interface pointing towards the other router. So in this case, you type in interface gig 1.67, and you would type in xconnect, and you would say the address of the peer is 10.1.67.6, and you would say the virtual circuit ID would be, say, 200, and then you would say encapsulation is MPLS. So that's one way you could run. This is basically any transport over MPLS or Ethernet over MPLS, so you could provide, and this is assuming that your customer's attachment circuit is Ethernet based. So you could do that. So just for kicks, I'm just going to, incompatible with IP address, command rejected. Like I'll have to take a look at that, but this gives you the idea. So sudo wire 0 is up. Just for kicks and giggles, let's go ahead and configure it. Interface gig 1.67, and then xconnect 10.1.67.7, 200. Encapsulation is MPLS. Show xconnect. Yeah, CSR doesn't support this. And the reason why I know that is we're going to do VCID, or VCID is 200. At the moment it is not even there. So, but this would give you the ability to run Ethernet over MPLS. I don't think the CSR support this, but it's a capability that's there. I just watched the video a few hours ago, and I was like, oh, that's kind of cool. So that gives you one little advantage. The other one is if you're underneath the interface gig 1.67, I think, what is the command? I forget. Encapsulation, is that what it is? No, that's .1q. .1q. Yeah, that's not it. It is. What is it? Where is it? There's a way to run overlay transport virtualization. It's actually a really, really cool command, and I'm not remembering how to do it at the moment. So let's see if it's out here. Yeah, I'm not sure. Oh, right there, OTB. OTB. Yeah, see, you can run OTB, and what OTB basically does, if you're not familiar with it, and I come from doing a lot of VMware stuff, so unfortunately it's one of those things where I kind of have to know what it is. Basically, this is the way that it works. This is what the purpose behind it is. So, for instance, if you have a ESXi host, okay, you have an ESXi host, and you have another ESXi host. And by the way, I'm a VMware certified professional. and I'm working on my VMware Certified Advanced Professional in Data Center Administration. So it's not really doing anything at the moment because I'm studying my CCIE, but still. And let's say you have a virtual machine sitting here. It could be any operating system or application. And same thing over here. You have another one over here. What you have here is we're going to draw a JBOD, or just a bunch of disks. So this is going to be a bunch of spinning platters in a SAN or a NAS. And so what you do is you connect this guy to here, and you connect this guy to here. So basically what you do, and for the argument, we're just going to run this as iSCSI. Now iSCSI allows you to run SCSI over IP. So basically it allows you to run storage protocols over your IP data network. Now normally what you would do is you would do what they call vMotion. Now vMotion requires you to have shared storage between your hosts, and you have to create a VM port group that's going to allow for vMotion traffic to go across it. And typically I recommend to have a dedicated connection for this. Now these guys have to be layer 2 adjacent to each other, so they have to be on the same broadcast domain. So what you would do is you'd put a port group in there on the same subnet, and away you would go. And from there, what would end up happening is you'd be able to move this guy to this guy. So you'd have eventually two hosts on, or two guest operating systems on this guy. And what ends up happening is this guy always owns the storage. So he's taking a look at the storage. So you're just moving the memory consumption to this guy. That's all you're really doing. Now that is standard vMotion. You have storage vMotion, or storage vMotion means is you're going to move it from one storage to another. And the cool thing about that is when you're doing that is you're able to take that information, and let's say for instance right here it's thick provisioned. Now thick provisioning, I don't want to dive too deep on how this stuff works, but thick provision means that you set a dedicated reservation for hard drive space, so like 100 gigs, and you set it up to where you're going to zero out and hold that 100 gigs. Now you have lazy zeroed and eager zeroed. Lazy zeroed means it's only going to zeroize whatever's used up to that point, but it's going to dedicate 100 gigs to that device. Eager zeroed means it's going to zero out the entire, or zero, I mean binary zeros, the entire 100 gigs, and not let any other operating system or device or service or source on that host have any of that hard drive space. Now, if this guy is thick provisioned and you want to move it to this guy, what this gives you the ability to do is it gives you the ability to do a provisioning change. So you can provision from thick provisioning to thin provisioning. Now, thin provisioning is similar to thick provision lazy zeroed, meaning it dedicates 100 gigs, but it only uses whatever's allocated up to that point. It doesn't zero out the whole 100 gigs and allocate it. What thin provision does is, let's say you have 100 gigs of hard drive space, and you have and you start dedicating, say 20 gigs to another machine, 30 gigs to another machine, 40 gigs to another machine. So that right there, and then we allocate another 20 gigs to somebody else. You've what they would consider to be over provisioned your storage to your guest operating systems. But the nice thing about thin provisioning is it's only going to use what's needed. So for this guy, he only might be using this much, and this guy might be using this much, and this guy might be using this much. This guy might be using just this little bit, and this guy might be using almost all of it. But whatever's left over is able to get shared equally among all of the resources. So that's where thin provisioning comes into play. Now that's where storage vMotion comes into play, and then you're able to move from one source to another, but you have to have the capability of talking to multiple storage devices at the same time. Now with normal vMotion, it goes pretty quick. You're just moving you're moving the memory resources from one device to the other. That's all you're really doing. Standard vMotion takes just a few minutes. It goes pretty quick. Storage vMotion takes much longer because you have to physically move the hard drive information from one to the other, and the hard drive has got to get moved before the actual operating system gets moved, because if that was to happen, if you're, say, booting from SAN to where the actual operating system isn't local to the data store on the host, it's going to drop. It's just going to blue screen on you because there's no hard drive. It's like you unplug the hard drive. So Storage vMotion typically takes a little bit longer. Now, the point of all of that explanation is to explain how OTV works. Now, OTV, the way that this actually operates, is we're going to have this in Chicago, and we're going to have another data center over here in, say, New York. Okay. Now, normally what you would do is, in order for you to do vMotion and storage vMotion, all this stuff has to be layer 2 adjacent. So you have to have all on the same local network. So that's why data center networks are typically more flat in some areas than others. Now, I'm not a data center engineer. I'm more of a VMware guy. I don't design data centers. So if there's a data center guy listening to me, I'm stretching my experience here. Now, what OTV does is it takes the same concept over here where normally you would be limited to the data center you reside in. So normal physical location. Well, OTV allows you to take that say this host right here with this guest operating system here, and let's say for instance you want to route traffic. You know, you want to take this guy down for maintenance, but you have no other ESXi host available. And let's say for instance you have this guy's a 5.1 host, so ESXi 5.1, and you have a bunch. Say you have 30 5.5 hosts. Well, you can't move this guy to a 5.5 host because you'd have to upgrade a bunch of stuff in order to get there. So, like, you'd have to upgrade to VMS 5. Some other things would have to be in place in order for you to do this. Where this guy over here, he happens to have a 5.1 host and say 20 5.5 hosts, right? Well, you can't just unplug this guy, load it up into an email, and send it. Well, email's not big enough for that. You could FTP it. You know, you could do an say an OBF export, and then you could send it, via FTP to this guy. Then he could import and install. Yeah, that would totally work, right? Then you wouldn't need OTV. But that's why OTV is cool, because you don't have to do that. What OTV does is it allows you to bridge the layer 2 broadcast domains. So layer 2 network here and a layer 2 network here over an IP network. So it basically allows you to take that layer 2 restriction away and route it over an OTV tunnel, and it allows you to bridge the gap. So it's almost like dealing with the old-fashioned bridges, where you wanted to connect two disparate networks, you put a bridge in between them. So that's basically what you're doing. Now the drawback to that is, not the drawback. It's typically referred to as MAC and IP routing, because what you're doing is you're actually reserving the MAC address as information, so your layer 2 info here, and then you're encapsulating inside of, I believe it's GRE, so it can be routed. And I believe it gets routed over MPLS, or it's one of the capabilities. So that's the idea of OTV. And that's a high-level overview of how it actually works. So you're able to migrate a live working virtual machine from one data center to another data center in two physically different geographic locations. So it's actually very, very cool. So it gives you that capability right there. Now that's the high-level overview. I'm not going to get into how to actually configure it or anything like that. My premise to this, and the reason why I think it's actually really cool, is because when you're dealing with that type of stuff and you have the capability of moving stuff from one data center to the other, that totally unleashes what you have the capability of doing. Now, I happen to be doing some consulting for a company that has the capability of doing that, and I brought it up to them, and they just kind of looked at me kind of funny, like, you can do that? And I was like, yeah, totally. You want to? And now they've got Nexus 7000s and whatnot in their environment, so they've got the hardware resources to do it. It's just that, actually getting it implemented and stuff like that is going to be the fun part. But that's just a general idea of how this stuff works. So, again, I'm not a data center engineer. I think some of the data center technologies are pretty cool. But, it gives you some flexibility that you may not have had, 5-6 years ago. So, lots of cool things are coming out. And then again, I'm a VMware guy. So, you're going to hear VMware stuff coming out here and there, just because of the fact that I happen to still work on the VMware networks and stuff like that. So, but enough ranting from me. I hope this has been informative for you, and I'd like to thank you for viewing.